Alright, today we're going to look at solving systems of equation by substitution, or a method other than what we've been doing, which was just graphing. So we're just going to learn how to solve this by substitution. So remember that a system is two or more equations that are taken together or looked at the same time. Right now we've learned just to solve them by graphing. And when we solve them, we can get one solution where the lines intersect. We can get infinitely many where they're the exact same line. Or if they're parallel, we can get no solution. So here is the graph of this system, y equals 4x plus 2 and y equals negative 2x minus 3. Notice that our intersection, isn't it a lattice point or a point where we can actually check to see what that solution is? So graphing isn't necessarily the best method at all times. Now this is the steps to solving by substitution. It's going to seem very confusing when I read through it, but I think once you see it, you'll understand. So what's going to happen if the equations aren't solved for one of the variables, either x or y? We're going to have to solve one of them for either x or y. We're then going to sub the expression into the other equation and solve it. That'll give us just one variable in the equation to solve. And then we're going to substitute what we found into the other equation. So if I look at this system, notice that y equals 2x is that first equation. So it's already solved for y. So I'm going to substitute 2x for y into the second equation so that I get 7x minus 2x equals 15. And I would get into the habit of writing whatever you substituted in parentheses, because it makes it so that you don't forget to distribute when it's not just one term. So 7x minus 2x is 5x. And now we just divide by 5. So x is 3. Okay, now that you've got a value for x, you can sub it into either equations. So if I take the first equation, y equals 2x, and put in 3, I'm going to get y equals 2 times 3, or y equals 6. So our solution is 3, 6. I could also, if I had wanted to, put it into the second equation. You don't have to put it into both, but I'm just going to show you that it works. So 7x minus y equals 15. 7 times 3 minus y equals 15. So 21 minus y equals 15. If I subtract 21, I'm going to get negative y equals negative 7. And dividing by negative 1, y equals, I can't subtract, it should be 6. Notice that it was a lot easier to put that into this equation. So you want to make it as easy as possible. While it works for both, pick the easiest one. Pick one without fractions, pick one without coefficients. Just pick the easiest one. Okay. In this case, in this example, notice that both of my equations are solved for y. Okay. So that means that I can take this expression and put it in for this y. So 2x plus 2 equals negative 3x plus 4. Okay. Again, I now have an equation in one variable, so I can solve that by adding 3x to both sides. And I get 5x plus 2 equals 4. If I subtract 2 from both sides, I'm going to get 5x equals 2. And then if I divide by 5, x equals 2/5. And we're going to leave it as a fraction. Again, it doesn't matter which equation I'm going to put it in for. I don't like negatives, so I'm going to put it into the first. So I get 2 times 2/5 plus 2, putting the 2/5 in here. So if I multiply, remember this is the same as 2 over 1, so I get 4/5 plus 2, or 2 is equivalent to 10/5. So y equals 14/5. So my solution is the ordered pair 2/5 and 14/5. Notice that I use parentheses because it's an ordered pair. Last example. Notice that neither of these equations are solved for y or x. So what I'm going to do, this first one, this has no coefficient in front of the y, so it's easier to solve that equation. So I'm going to take the negative 2x plus y equal to -1, and I'm going to solve it for y by adding 2x to both sides, so that I get y equals 2x plus 1. Now I can take this and substitute it in for y over here. So I get 4x plus 2 times, it's important that you use parentheses here because we want to make sure that you're distributing. So now I'm going to distribute my 2, and again, this is an equation of one variable like we know how to solve. So 2 times 2x is 4x, and 2 times 1 is 2, and that equals 12. So I get 8x plus 2 equals 12. If I subtract 2, I get 8x equals 10. Divide by 8, x equals 5/4. And then I can substitute it in whatever equation I want. I'm actually going to substitute, because they're equivalent, into the one that's already solved for y. So I'm going to put it in right here. So I get y equals 2 times 5/4 plus 1. So 10/4 plus 1, which is the same as 4/4. So I get 14/4 or 7/2. So my solution would be 5/4 and 7/2. Oh, I lied. I guess it's not the last example. Sorry, I shouldn't do that to impressionable young minds, especially those who like cheese.
I like cheese.
So I'm going to take this x and I'm going to sub it in here. So I get -3 times -1/3 y plus 2 plus y equals -6. When I multiply -3 times -1/3, oh, it should be +1/3, sorry. I get -1y plus 2 plus y equals -6. When I combine my like terms, my y's cancel out. Notice that? So -y plus y is 0. So I get 2 equals -6. Once again, that's a false statement. So that means that there is no solution. If I were to get a true statement, it means that there would be infinitely many solutions. So here are your steps for solving by substitution again. Pause it, take a look over it, see if they make more sense to you. So hopefully today you learned how to solve a system by substitution. Have a math-tastic day.